guys, we're here to do our science experiments about energy.
Give me something new. I want it back through and through. Just do it. I let you go. I know you like to break the rules, and my cry is being too good for you. I'm too good.
Hi everyone, we are going to start our energy experiments and I'm so excited about it. The first experiment, you will need 2 water bottles. One has been cooled in the refrigerator and one has not been. 2 glasses that you can see through, a piece of paper, and an insulator. Now, we haven't yet gone over this lesson in science, and we're really probably not going to get to this particular matter. So I'd just like to tell you that some objects conduct heat easily, and some objects do not conduct heat easily. Now, an insulator does not conduct heat easily, and that's why we use oven mitts that are made of cloth and rubber, because heat can't easily pass through these materials. Now, conductors easily pass through those materials. That's why you wouldn't want to use a metal spoon in a hot bowl of soup that you just got from the stove. Now, to start off, you are going to need the red food coloring in the bottle of water that has not been cooled. This is going to be your warm room temperature bottle of water. And I'm starting off with 3 drops, so let me just see how much this spreads. Perfect. Okay, you don't want it to be too red. And then for the cool bottle of water, you're going to use the blue food coloring. And so I don't want it to be too dark. I want to see the difference. When it comes time, you'll know what I'm talking about. So I'm going to try 3 for that one too. Put on the top, shake it around. Perfect. Now, what you're going to need this insulator for is you're going to have to take some of this red water and put it in the microwave. And I'm going to heat this up. So I just took my glass of water from the microwave, and actually it's not that hot. It doesn't need to be super hot, but just in case, make sure you have one of these. I only heated my water for about 40 seconds, and this was only about 8 ounces of water, and so it should take about 40 seconds. You don't need it piping hot. Now, I already have the hot water in this glass, and so now I'm going to pour the cool water into the other glass. Okay. Now this could get a little messy, so you want to make sure that you're doing this in the kitchen. Now, this is our moment to hypothesize. What I'm about to do is take an index card, put it on top of one of the glasses, and turn one of the glasses over and see if the water mixes. I'm going to take the hot water, turn it over, and as you can see, because of the air pressure, it keeps it in place for some time. Put it on top of the blue glass. Oops. As carefully as possible. As you can see, I've already lost some of mine. All right, and so now I'm going to take my piece of paper away. And we're going to see what the 2 different temperature waters do. Whoop, well that's spelled. There's not a perfect seal, but if you can really look at it, you'll see that the red stayed on top and the blue stayed on the bottom. That's because when particles that are heated begin to have more kinetic energy and move around, the particles spread out and they become less dense. This water is actually less dense or less heavy than the cold water. Those particles are more packed together, and that's why the water doesn't mix. Now I'm going to turn it over and see what happens. could be a disaster. Now it's purple. As you can see, the water has been completely mixed because the red water and the blue water changed places and it's no longer separated. Now, I have to freeze this to tell you that it wasn't because I moved the glass over that the waters mixed. It was because the red water would not stay in place where I put it when I moved it over. Immediately, even though I put it on the bottom, it moved to the top. And the same with the cold bluer water. Even though I put it on the top, it moved to the bottom. It did not stay in place after I turned the water over. That's because hot water and air always rises when they're heated, and the heated particles will always rise to the top, even if you try to manually put the heated particles on the bottom. That is the amazing quality of convection when it comes to heat transfer.